So in this video, we're going to review properties of exponents. And the first one is the product property of exponents, which happens when we are multiplying like bases. We have x to the fifth power times x to the second. Exponents are just a shorthand for repeated multiplication. So when we have x to the fifth, that means we're doing x times x times x times x and times x. There's 5 of these x's. We are then multiplying that by x squared, which is just x times x. So this repeated multiplication, we see 7 x's, so that's x to the 7th power. What happens when you are multiplying like bases, like x to the a power times x to the b, will be just adding your exponents together, so the a plus b power. This is what happened in that first example with x to the fifth times x to the second. We add our exponents and get x to the seventh. When we see something like this third example, you have a little bit more than exponents to deal with, because -6 and positive 5 here are just regular integers. They are not exponents. So we're going to treat them like we normally would, because that's -6 times 5. We get -30. And then a to the fourth power times a to the first power is a to the fifth power. B to the seventh times b to the 10th makes that b to the 17th power. The second property we have is the quotient property of exponents when we are dividing like bases. So if we have x to the 8th over x to the 3rd, going back to just what exponents are, x to the 8th would mean that I have a product of 8 x's, and we are dividing by x to the 3rd, so 1, 2, 3 x's. Because we are dividing these, x divided by x is just 1, x divided by x is just 1 again, and x divided by x a third time. We're left with 5 x's in the numerator, which is just x to the 5th over 1, or just x to the 5th, because we don't have to write divided by 1. So based off that definition, we are looking at subtracting these exponents. So this becomes x to the a minus b power. With this third example, we can use this property of exponents, but 2 and 8 are not exponents. So that's one of the biggest mistakes that I often see, is trying to apply that property to things that are not exponents. So if I was to reduce the fraction 2/8, that would just reduce to 1/4. We have a to the 5th divided by a to the 3rd. That means there are 5 a's on top and 3 on bottom. If I was to reduce out the factors, I would have a squared on top, which follows with subtracting our exponents, 5 minus 3, a to the second. All right, then we have b to the 4th divided by b to the 1st, which is b to the 3rd. So you could write this out as 1a squared b to the 3rd divided by 4, but you also don't have to have the 1 there. It's just a squared over a squared times b cubed over 4. The third property we have is the power property of exponents, often called a power to a power. So when we have a power to a power, we're going to end up multiplying these exponents. This happens because we have x cubed squared, which means there are 2 of these x cubes, which becomes a multiplying like bases property, and we get x to the 6th. So the shortcut is to use that power to a power property, which means I'm going to multiply 3 times 2 and get to the 6th. So if I have x to the a power to the b power, that whole thing's to the b power, we have x to the a times b power. So in the third one, this -2 a to the 9th power times b to the 4th, that whole thing is raised to the 5th power. We can't apply the power to a power property if we're not using exponents. So if I have negative 2, that is just an integer. It's not an exponent by itself. Its exponent is just negative 2 to the first power. So if I was raising this to the 5th, I'd have negative 2 to the 5th power. We have a to the 9th power, and then we're raising that to the 5th power. We have b to the 4th, that's going to be raised to the 5th power. Using this power to a power property, that would have given us a to the 45 and b to the 20. So a to the 45th power and b to the 20th power. But with negative 2 to the 5th power, that's negative 2 times negative 2 times negative 2 times negative 2 times negative 2. There's 5 of them, which ends up being negative 32. So our final answer would just be negative 32, a to the 45th, and b to the 20th. In this next property, we discuss zero exponents. But when we think about zero exponents, I want to first think about the fraction 5 over 5. 5/5 would be equivalent to 1. If we use a variable, even if I had x over x, x divided by x is 1. And so if we discuss those exponents that are happening, we have x to the first divided by x to the first, which would be equivalent to x to the 1 minus 1 based off of our quotient property, which makes that x to the 0 power. Since that's equivalent to 1, x to the 0 power is equivalent to 1. So what we'll see is that anything to the 0 power is 1. It doesn't matter what the base is. If the base is raised to the 0 power, it is equal to 1. So even if I had something that looks a little complicated, like 4x squared plus 7x minus 13, if that whole thing is raised to the 0 power, then that is equal to 1. And I'll give a third example here as well. If I had x to the 0 plus y to the 0 power, then that would be, I have 1 because that's x to the 0 plus 1 because of y to the 0. So it equals 2. In the fifth property, we have negative exponents. So let's look at some pattern recognition again. I'm going to do 2 to the third, to the second, to the first, to the 0 power, and then go to the negatives, 2 to the negative power. So if we look at some pattern relationships here, 2 to the third power means 2 times 2 times 2, which is 8. 2 to the second power is 4. 2 to the first is just 2. And 2 to the 0 power, we just saw, was 1. So our question will be, what is 2 to the negative 1 power? Well, if we see what's happening as we increase the exponent, we're just multiplying by another 2. So we went 1 times 2 is 2, times 2 is 4, times 2 is 8, times 2 would be 16, and we could keep going forwards. Or we can go backwards and we can divide. So if I went backwards, we'd have 1/2. We could continue that pattern and we would see 1/4, 1/8, and that's happening when we get these negative exponents. So if we have 2 to the negative 1 power, it's equivalent to 1/2, but 2 to the negative 2 power was equivalent to 1/4. What happens when we are doing a negative exponent is it involves the reciprocal of that fraction. So if I have x on top, I'm going to move it to the bottom and the exponent becomes positive. So x 1 over x to the first. If there was x to the negative n power, then that would be 1 over x to the positive n power. That's what happened in something like 2 to the negative 2 power, because I would move that to the bottom of the fraction and make that 2 squared, but 2 squared is 4, so 1/4. Same with 2 to the negative 3, that became 1 over 2 cubed, which is 1/8. In this third example, we have something a little bit more complicated looking because we have multiple properties going on. So I have 5a to the 7th times 3a to the fourth to the second power. I'm going to first get rid of this negative exponent and think of this as 1 over 3a to the fourth. The whole thing is raised to now the positive 2 power. It's still being multiplied by 5a to the seventh, but I'm not going to deal with that yet. I still want to deal with this exponent of 2. So this would be 5a to the seventh times 1 over, and let's think about what is 3a to the fourth squared. That would be 3 squared, which is 9, and a to the fourth squared. So a to the fourth to the second power, that becomes a power to a power property. So a to the eighth, because we are multiplying multiplying the exponents when we have a power to a power. Next, we could finally deal with the 5a to the seventh, which would just make this 5a to the seventh times 1 in the numerator. So 5a to the seventh over 9a to the eighth. We can finish this out dealing with our quotient property because we have a to the seventh over a to the eighth. If I subtract those exponents, I'm going to have negative 1, which pushes it to the bottom. So 5 over 9a. Five over 9 could not reduce any further, so we didn't do anything with those integers. Now, one property that people will ask about is, well, what happens when that's a fraction? So if I have 2/3 to the negative 2 power, that fraction still is put into the reciprocal. So I take the reciprocal and make that 3/2, and it's raised to the second power. That's 3 squared over 2 squared, which becomes 9/4. If that had variables, you maybe had 5a to the fourth over b to the third, and you raise that to the negative 2 power. It's still going to take the reciprocal, so b to the third, 5a to the fourth, and they are both raised to now the positive 2 power because we have taken the reciprocal. So that's b to the sixth over 25a to the eighth.